This video is the start of sequences in series, and we will first look at arithmetic sequences. So an arithmetic sequence is formed by adding or subtracting the same number to get to the next term. So this first little example here, our terms are 1, 4, 7, 10, 13, which therefore has a common difference of positive 3. Then our next one, we've got 19, 15, 11, 7, 3. If we look at that little sequence there, that has a common difference of negative 4 because each term goes down by 4 each time. In the first one, each term went up by 3 each time. In general, if the common difference is D, then the first term we call it U1. I'll just put an underline that here. Second term would be U1 plus D, which is the difference. Third term would be U1, the first term plus 2 differences. The fourth term, the fourth term will be U1 plus 3 differences, and so on. From the information, we can then create this formula, which is UN equals U1 plus, in brackets, n minus 1D. Now for this, n is the nth term, so the term we're trying to find. U1 is the first term, and D stands for the common difference. Let's do a few examples. Example 1, an arithmetic sequence has first term 7 and common difference 8. Find the 10th term. So just go back up to the formula here. We have UN equals U1 plus, in brackets, n minus 1D. Sub in all the information we know. First term of 7, so U1 is 7, plus the term we're trying to find, which is 10, so we're trying to find U10. So it'll be 10 minus 1, and our common difference is 8, so that's multiplied by 8. And then when you work that out, you will get an answer of 79. So the 10th term in this sequence will be 79. Example 2, the third term of an arithmetic sequence is 10, and the 15th term is 46. Find the equation of this sequence. So we're told in the question that U3 equals 10, and U15 equals 46. We're wanting to find out what UN equals. So our equation. Now we can make this into two equations. If we know that U3 equals 10, then we know that 10 would equal U1 plus 3 minus 1D, and U15 equals 46. If we put that into the equation, it would be 46 equals U1 plus 15 minus 1D. Let's simplify the two equations. So 10 equals U1 plus 2D, and then the other equation will be 46 equals U1 plus 14D. And then solve simultaneously however you would like. And when you do that, you will get an answer that U1 equals 4 and D equals 3, which we can then put in our equation. So UN would equal 4 plus n minus 1 times by 3. And that's the equation of the sequence. Example 3, find the number of terms in the arithmetic sequence 1, 4, 7 all the way up to 100. Let's look at what we know. So U1 would equal 1, that's the first term. Our D would equal 3 because each term there is going up by 3. So 1 to 4 is 3, add 3 again to get 7, and so on. So then in our equation we'd have UN equals 1 plus n minus 1 multiplied by 3. Now we know that the term we're trying to find is 100, which means the UN would be the 100. So 100 equals 1 plus n minus 1 multiplied by 3, and we want to solve for n. Do some rearranging here. Minus 1 from both sides. We'd have 99 equals n minus 1 multiplied by 3. Divide both sides by 3, and we'll end up with 33 equals n minus 1. Then add the 1 to both sides, and we'll have 34 equals n. So 100 is the 34th term. Example 4, find k, given that k plus 5, negative 1, and 2k minus 1 are consecutive terms of an arithmetic sequence. We want to find out what k is. So to do this, the easiest way would be if they're consecutive terms, the k plus 5 and minus 1 must be the same as minus 1 and 2k minus 1. To find the difference, we want U2 minus U1 will give the difference between those. So minus 1 minus k plus 5 must be the same as u3 minus u2. So the 2k minus 1 minus 1. The difference must be the same between the terms. From this then we can just solve for k. So we'll have minus 1 minus k minus 5 equals 2k minus 1 plus 1 when we get rid of all our brackets. Simplify this down, we'll have minus k minus 6 equals 2k. Add k to both sides, we get negative 6 equals 3k. And then divide and we'll have negative 2 equals k. And then we can always check that if we would like. So if we put negative 2 into the term, so k plus 5 would be negative 2 plus 5, which would give 3. And then our next term would be negative 1, and our last term would be 2k minus 1. If we sub in our negative 2, we'd have 2 times negative 2, which is negative 4 minus 1, which is negative 5. And then if we look here, the difference between 3 and negative 1 is 4, and the difference between 1 and negative 5 is also 4, which means it works with the k value that we found. And that is the end of arithmetic sequences.